Hi everyone, it's the Christmas and New Year's holidays, and I feel that this is the perfect time to pass on the files to one of my neatest inventions to you guys. This is the Carlson Super Probe, and I designed this some time back. For those of you that haven't seen the original video, I'll link it just below this video here. There's actually quite a bit of information in that video on the assembly procedure of this device. Now, I've never passed on the original printed circuit board files or component maps or anything like that, and that will be linked just below this video in the attachments. So everything will be in PDF. The printed circuit board files will be in PDF as well, so you can directly print them and do the toner transfer method. The printed circuit board files for this particular part here is a double-sided board, and I'll go over that here in just a moment. So what I'm going to do is I'm going to go to that original video, my original video files, and I'm going to pull out a couple of the sections that really explain the assembly procedure of this, and I'm going to put it in this video right here. So if you're going to watch the original video, you'll notice that some of the parts are repeated in this video here, and that again is just for ease of assembly. So I'm not sure, maybe 4 or 5 parts, something like that should probably do that. So the attachments that are going to be below this video will be this schematic here. I'll have this in PDF. So this is the probe head itself. So this is the part that you hold in your hand. This is the audio amplifier here. This will also be included in PDF. Now, this audio amplifier is a really nice amp to use for anything. If you want to make something for some computer speakers, or say you want to listen to your MP3 player, CD player, whatever it is you have, you can pretty much tie it into here and use this thing as a general purpose audio amplifier. It works very well. So there's this. There will be the component map. So all of this will be included here. And so this is the component map for the part that goes in the probe, so the head, and the component map for the actual audio amplifier itself. Now, if you want to, say, go over this thing and move parts around or redesign something or do something like that, make sure that you always use a star grounding system with this IC right here. So if you just basically run all the grounds all over the place, you will make a very nice oscillator with this IC. Very, very important. It's very finicky, so you have to have a star grounding system with this. So this will all be included in the attachments just below this video here, and now what I'll do is I'll link those parts in, and you can take a look at that. So the whole idea of this super sensitive RF and AF probe is really just to improve upon the design of this probe that you saw in the Hammerland HQ140X video. Now don't get me wrong, it's an absolutely great probe to use with a signal tracer that's already built, like an ICO, Heathkit, or some sort of night kit signal tracer. No problems whatsoever. For a non-active probe, this is a really highly sensitive probe, but when you compare this probe to what's in this folder, this just turns this into a low to medium sensitivity probe at absolute best. So when I started putting this thing together, getting back to the original story there, was a while back, and I started building this on a breadboard and then kind of went to dead bug style. And I wanted to save the, the final design of this when I build the circuit board for a video so I could share that with you guys. And that's what I'm going to do in this video here. So looking at the design of this, it's a relatively simple design, and there's a whole bunch of things that were running through my head when I was putting this thing together. First of all is I'm going to share this design with you guys, as you can see here. So I want to keep the parts as common as possible. So I want to use just, very common parts, and I want to use as many of the pieces over and over again so you don't need to buy a whole bundle of different parts. So to give you an example, all the transistors are all NPN 2N3904s. They're just about as common as dirt, right? You can see I'm reusing the same values, 3.3 meg, 15K, 3.3 meg, 15K, 3.3 meg, and so on and so forth, all the way through the schematic here. So it really was about a minimalist design. It was about the right balance to make the probe work very well and keep component down. So there's a whole lot of things going through my mind at the time when I was putting this thing together. As you can see, lots of values are repeating all over the place. So how this thing works here, it has 2 separate functions really. I'll start just explaining how the front end works here. So we have 2 common emitter amplifiers here. So at this point here, we have a pretty stout signal with almost nothing here. In fact, this amplifier is so sensitive that it's creating its own noise at this point. Now, you'll see here at the emitter of this transistor, this here is an emitter follower. we can bypass this section here and just go right to another emitter follower that's just basically driving a cable, and that runs down into the amplifier, which I'll explain here in just a little bit. So this is for when the switch is in this mode here, bypassing this one section here. It's basically for sniffing out very, very low-level audio circuits and stuff like that. So if you have a problem in a transistorized audio amplifier, or say there's a very low-level audio signal or even some RF somewhere, and you want to basically sniff out where it's gone missing, this is going to do that very well. Again, you know, this is a non-contact style probe, and this is so sensitive that you can only have just a little bit of the probe end exposed. And by having that probe end exposed, it'll pick up the audio signal in an RCA cable or any kind of audio cable just by holding it close to the end. It really is that sensitive. So very, very sensitive. And when I designed this, I wanted to give it a variable gain so that we can basically turn this probe gain up and down. We can also turn the audio gain up and down in the amplifier. So this is all taken into account when I'm putting this thing together. Now, if we move the switch over into this position right here, what ends up happening is we enable this little circuit here, so it's no longer bypassing this. And this circuit is very sensitive for detecting crackling, popping, and even mild RF levels really is what this is for. So you'll see that there's an adjustment right down here, which is a 100K potentiometer. Now this is designed to be a set it and forget it kind of control. So this is going to be hiding within the probe. I don't plan on having an external control for this VR. And I'll get into that when I set the whole thing up here in just a little bit after it's all designed. But you'll see that this VR is on the base, and there's a 330K resistor above this. Now this is basically a fine adjustment to basically take this transistor and turn it off, make it quiet. So what's happening here is the front end of this is making so much gain. It's basically creating its own static and noise at this point. So by adjusting this, when the switch is in this position here, you're basically pulling this transistor into an off state. So it's kind of squelching the noise in the front end. Now, here's the trick. This is so sensitive that any kind of crackling or popping will create large excursions in the signal, and it'll very easily override this, and it makes a very pronounced clicking and popping noise in the speaker because of the detection in this section here. So it works very well for, finding that just very minute kind of hissing, popping, crackly components like a, bad resistor or capacitor or something like that. This here is just an indicating circuit just to help you realize when you're close to an RF or audio signal, this little LED will light up. And if you're in a crackling or popping circuit, this little LED will, flutter and kind of go on and off with the cracking and popping. So that's just there as an indicator. So that's this circuit here. Now, another thing I kept in mind is that I don't want to basically be running any kind of special cable out of this probe down into the amplifier or power supply unit. I want to just take a standard, balanced audio cable or something like that and use it. So, for example, if you have a piece of audio cable with some XLRs on it, it'll have a red, a white, and a shield inside it. You can just use a piece of cable like that to run from the probe down to the amplifier. So this circuit, when there is no signal and it's just sitting on your bench listening to static, basically just standing there, this just probe head alone will draw 780 microamps. So not even a milliamp. When the tip of this is in the presence of a very large signal, so say you bring this close to an oscillator coil or something like that, and this green LED is really bright, this probe draws 2.3 to 2.5 milliamps maximum, which allows me to control the voltage with just a simple VR. So we can adjust the probe voltage supply with just a 2K, standard VR. Half watt VR will be absolutely fine for that. On the wiper, we have a 4.7 microfarad capacitor here just to keep any noise off and all that kind of stuff, from the VR. And, if depending on the length of cable that you're running up there, just to basically keep it clean, that's all. Now, I build this around the parts that I have, and I had a rail full of LM4871s, and I also have a rail of LM4891s. The 4871 is a 3-watt version, so I ended up using that. Very simple circuit to use. The only catch with this is that it needs to be around 5 volts. I'd say 5.5 maximum. So in mine, I plan to use some nickel metal hydride batteries for AA's. So you really don't want to exceed about 5.5 volts with this. If you do, you're going to probably have to run a current limiting resistor in line with this IC, or you might damage it. So that's all in the spec sheet for the LM4871 or like below. Very nice circuit, very simple to hook up, no capacitors in line with the speaker or anything, right out of the IC, right into the speaker. Really nice design, very minimal amount of components around the IC to make it work. I did add one amplification stage here, and that's just comfortable to basically bring it up to make this thing operate like a normal signal tracer. You'll have ample audio or a volume level with this little amplifier here. In fact, even without the amplifier, if you wanted to eliminate this and run that in there, it's going to be a little quieter. You won't have the the range, and it would still work fine. If you come across a strong signal, it's still going to get loud. But this just allows you to turn the probe gain down and turn the audio gain up. It's basically why I added this here. And when I demonstrate how this thing works, I'll show you exactly how that all functions. So just, this, you can use a 4.7K potentiometer here with this switch over here. This is just a standard, any kind of, potentiometer. If you have a 4.7K potentiometer, use it. If you have a 10K potentiometer, the switch on it, use it. It's not really picky. And you can see that one end of the potentiometer is tied right to ground. The other end goes through the white cable and directly up to the emitter up here in the actual probe head itself. So all you're doing is you're bringing the wiper of this transistor here closer to the signal or closer to ground, just to give you your variation in volume level or audio gain level. Now, you see how I have a 10K resistor here in the probe with a star beside it? If you wanted to use this with a standard signal tracer, you can do that. Just put a 10K resistor up here in the probe, and then you just have audio running out of this. And usually most signal tracers like ICOs and Heathkits and Nightkits, they all have a blocking capacitor right at the jack. So that blocking capacitor would block any DC from going into the machine at that point. So that would be absolutely fine. If there is no blocking capacitor on the input of your signal tracer, you would need to add one. That's basically what this is here. This 4.7 microfarad capacitor is just basically isolating this section from the VR. If not, when you move the VR around, it would affect the bias of the transistor and all sorts of things, right? So that's how that works there. And I think that's pretty much all for this little section here. This is the circuit board layout that I've come up with for this probe project. So what you see on the screen will fit inside that probe shell. This has nothing to do with the amplifier yet at this point. Now, what is on the screen is enlarged quite a bit so that we can take a look at it. The real size of this board is right about there. And that's even larger than the original little board that was in that probe to begin with. Now, they had a small circuit board inside the probe that kind of held some through-hole parts. You would just twist them together through holes and stuff. This is the little board right here. And you can see that there's 3 little slots right here. The switch would fit into that. And then you would, put a diode or a resistor through these holes, twist things together and solder it. And this could be used as a coax strain relief and stuff like that, right? Now, the probe ends, the red and black probe ends, were actually quite a ways away from this, so there's a bit of room on each side, so I wanted to optimize on that. So I measured the distance between the actual probe, and I could make the circuit board a little bit bigger, so you can see that the board itself is just a little bit bigger than the original board. Now, I'll just enlarge this again. So the switch won't fit here. I don't have provisions to, basically cut a little slot here, so I'll just drill the holes. It's large pads and the switch should fit right in there. Now, another thing about prototyping boards like this is the plated through holes. For all of your vias, you have to put a wire through and solder it on both sides of the board, and that's what all these little red dots are here. They're all little vias to the other side of the board. Now, you can see that the green side here is going to be the top side. The black side is going to be the bottom. So that'll be a ground plane layer or a common layer in this probe to just create some shielding. I wanted as much as that as I could get on here. So you can see that these traces are on the upper side of the board, and when I sit the switch down onto this board, I'm going to have to elevate the switch just a little bit so I can get a soldering iron under the switch to solder these pads here. Reason being is because there is no basically plated through hole between this. So if I solder the bottom side of the board, nothing will creep up to the top side and connect this to the switch, so I'll have open connections. So again, that's what happens when you prototype like this. So normally in a case like this, if I had more room, what I would do is I'd just put, say 3 vias here, bring the connections to the bottom side of the board out of the way of the switch, and then just solder them on the bottom side. But you can see everything's pretty tight here. So I'll just elevate this, use a thinner tip on my soldering iron, and just kind of get under the switch and solder them on the upper side and then on the bottom side. Not too big of a deal. If you're making single-sided boards, absolutely fine. And if these are exposed in an open area, putting a piece of wire through is fine. The size of the vias here is the hole size, roughly 0.018, something like that. The wire diameter will be around that as well. So you don't want the holes to be too big so that the wires kind of flop around in there. You kind of want to almost feed them through so that they're tight, so when you solder them on one side, when you go to solder them on the other side, you don't pull it through because it very quickly melts the solder. And depending on the thickness of your circuit board, that's could be a pretty fast process. Now I'm going to be using very thin circuit board for this, just because I want to fit this all in the probe shell, and I'm going to have to elevate this switch up too. So if I elevate the switch, it's going to put the circuit board lower, and I have to slide this inside that aluminum tube. So you'll see about all my plans and stuff when I put this whole thing together here. So a lot of measuring and stuff went into putting this thing together. So this is where the tip is going to be. So this will extend out to the tip. Now I plan on using a piece of coax for the tip and just expose a very small piece of that coax to basically act as the sniffer at the end of the tip there. This is the first common emitter amplifier here, and basically the signal carries through and goes into here, and it works its way around through this entire circuit. This right here is that 100K variable potentiometer or potentiometer. Now, if you're going to build this thing, you don't need to build it like this. If it's going to be in an entirely shielded shell like this Heathkit probe, you could put this thing together dead bug style, or something like that. Just glue TO92 components together and use standard through-hole parts, and it would be absolutely fine. Again, it needs to be in a completely shielded shell because this thing is so sensitive. And if you wanted to figure out the VR settings, find an area that's comfortable by playing with some resistor values. Once you figure it out, you don't need to use a VR. You can just put a couple of resistors together and just do it like that. So you don't even need to have a VR in there. Again, this here for me is a set it and forget it kind of thing. And again, this is going to be a pretty small layout. Again, everything is kind of optimized here, so I want to see what this thing is going to perform like on a circuit board. It worked out quite well on the breadboard with all the stuff exposed and a fence around it. So I'm expecting some pretty good results here. This is the circuit board layout that I've come up with for the audio amplifier portion of this project. I didn't know what to call the project, so I just called it Super Probe. So all these pads that you see around the perimeter of the board here all go to somewhere in that project box. So these 3 pads here run off to the stereo 1/4-inch headphone jack that will bring the power to the probe and the signal back to this audio amplifier circuit board. These 3 pads that you see here are the probe gain control, so these will just run right off to that VR. Same with these here. These ones here are for the audio gain control. Again, will run off to that VR, 4.7K and a 2K potentiometer. This is the power for the circuit board here, so this is the ground, and this is the positive 5 volts, or a little bit over 5 volts is fine. And this will run out to the speaker jack right here. This is a little audio IC here, and just associated components. This is a little transistor here and some tantalum capacitors, and the rest of the capacitors are ceramic style. These are some 0 ohm jumpers here, and 4.7 mic ceramic capacitor, and so on and so forth. So all the little 0402 components and everything that make this work. So the real size of the board is that big right there. So the way I'm displaying it here is so that I can easily work on it, that's all. So what I'm going to do now is print this off and put it onto a piece of circuit board and etch it and do all that kind of stuff. And once I've got that all done, we'll take a look at the etched circuit board. The circuit board is populated now and pretty much ready to install into the probe shell. So you can see I've mounted the LED on a little wire here. Basically, this is going to allow me to place the LED in an area that I can see it, and I figure that the only place that I'm going to be able to mount this is in this end cap here where the wires come out. So there's enough room in there that I can drill a hole on an angle in this end cap here and then have the LED point out kind of at me on an angle. The reason I want this to point directly at me because in a case of, some very, very light scratching and, very intermittent kind of noise, this is going to flutter a very light green color. It's not going to be super, super bright. The stronger the signal, the brighter the LED. And if it's, pointed off on an angle like this, you're not going to see it very well. You kind of really want this to be pointed right at you when you're searching for noise. So I'll probably have this in line with this switch here. So when I'm holding the actual probe, the switch will be, on the top side, and this will be just in line with that. So I'll see how that all works out here in the end. This is the actual probe tip. So this is a shielded piece of coax here, and this is the only area that's open here that's going to be doing any kind of sniffing. Now, there's no way that you could run this exposed all the way to that end. The probe would be completely unusable. It would pick up so much noise from, just surrounding things like, switch mode power supplies, and it would pick up hum and probably your soldering iron power supply on the workbench and all sorts of things. So it needs to be completely shielded. Now, the actual probe shell itself extends a little further than the circuit board, so this little exposed area here is absolutely fine. So for any experimentation that you're going to do with something like this, you could expose a piece of wire the same length as this, just beyond the probe shell here, and then that would be used for, sniffing and experimenting with this. If you were to extend this for, say, a centimeter or two beyond this probe shell, again, the board would be so noisy, this would be so noisy, it would be completely unusable at that point. So you can see that there's still a little bit of room on each side here, and that room needs to be there because the probe ends have this little area right here that slides into the aluminum like that. So it pretty much, it uses up the rest of the space. There's just a little bit left on each side for some movement here. What holds this entire board and everything steady is the two screws on the switch here, so that'll hold everything steady. Now there's quite a bit of measurement in getting this just right to fit in this shell here, just because I had to elevate the switch a little bit so that I could solder these connections here on the bottom side. So get my flashlight here and show you those connections there. Soldered quite easily. I really cleaned the leads of the switch very well and pre-tinned them before I put them in the board here. Put a little bit of RA type flux under there, and just basically touched them and it was soldered. And then I soldered the bottom portion of the board here as well. So on the bottom portion of the board here, you'll notice that there's a braid, and this braid is to ground this ground layer to the shell of the probe, which is, this shell right here. If the shell isn't grounded, it's just going to make so much noise from your hand holding it, it would be absolutely crazy and make this unusable again. So the actual switch itself is not grounded, the metal surface of the switch, so screwing this switch to the shell will ground this portion of the switch, and there's only one ground lead that's connected to the actual shell. So this whole area will end up being shielded and grounded. Very important in this application. Again, absolutely no solid plastic probe shells. If you want to use a plastic probe shell, you're going to have to coat the inside of it with some sort of a, spray-on conductive coating or something like that. Again, it'll be completely unusable unless this is entirely shielded. The probe audio amplifier is complete, and it went together pretty quick. So when I was installing the battery pack and the circuit board, I didn't want to drill any more holes in the box because, well, the artwork's already on top and it's done, and the box is painted. So what I did is I just used industrial strength super glue and just went in a zigzag pattern on the bottom portion of the battery holder here. And when I say industrial strength super glue, this stuff does not fool around. I've got one chance and one chance only to get everything straight. So I measured everything up and just dropped it in nice and straight, pressed the battery holder in, and at that point it's one with the box. It's not coming out again. It's the same thing with the circuit board as well. There's a little dot of super glue under the circuit board holding it in place. Everything was pre-measured. That worked out very nice. Didn't have to drill any extra holes. I kind of want to keep, the holes down to a minimum, keeps the box clean looking. So no extra holes other than what you've seen. So this is the jack that'll supply power to the probe, and the audio will come back in here. This is the probe sensitivity VR, this is the audio gain VR, and this is the switch for the whole unit right here, and this is the audio output jack on the back side of the box. So when the switch is on, it's basically taking everything that the batteries can supply and putting it across this VR right here. The wiper of the VR goes out to the actual probe, so if the cable was to ever short, or say the probe shorted, or say something accidentally got plugged into here that wasn't supposed to be in here, if I advance this potentiometer to its maximum position, the potentiometer would emit maximum smoke if it was, if the jack was shorted, right? So I definitely don't want that to happen. So what I've done is I've installed a small light bulb in series with the wiper, and that's basically in series with this jack here. So the light bulb itself is a 6 volt, 32 milliamp light bulb. So its cold resistance in the circuit here is 16 ohms. So the probe itself only draws, 2.3, 2.5 milliamps maximum, and that's under, a super, super strong signal, right? So it won't even know that this light bulb is here, but if something ever gets shorted, it'll save the VR, and I won't have to worry about repairing anything in the box. So basically, it's just acting as a current limiter. So, well, in fact, I can probably actually show you this thing here. We'll grab this here. The cable's just sitting off to the side. Plug it in here, and I'll turn this on. And I'll advance this to, there we go. It's full position. Okay, so I'll touch I'll short the leads out. So these are the leads right here. This is the audio lead right here. This is ground, and this is the positive. I don't know if you can see that there. So that's the positive that'll run to the probe. So what I'll do is I'll just short the positive, and you'll see the little light bulb in here light up. So I'll just do that right. Keep an eye on the bulb there. There we go. See, now if I was to do that and that little bulb wasn't there, that VR would be letting off the magic smoke right now. And as you can see, if I turn the VR, it just comfortably turns the light. Oh, that's me not pinching the light tight enough, or the wires tight enough. So as I turn the VR up and down, as you can see, it just basically varies the intensity of the light bulb, not hurting the VR whatsoever, and just protecting the entire circuit. All right, this should get you going on building your very own Carlson Super Probe. If you plan on putting this thing together, definitely share your results in the community section. It'd be great to see all the different ideas and design modifications that you come up with. For example, different probe shells or different case design. It'd be really neat to see an exact duplicate of this. See how close you can actually get to building this thing, just like what you see here. I have so many inventions and designs to share here in the future. Some that haven't even been built yet, some that are kind of just rolling around in the gray matter, and some of them that are in files and everything. So throughout time, we'll visit some of my inventions, and they may even become part of this course, and then I'll produce the printed circuit board files and everything and share that with you guys as well. So there's a lot of really neat stuff coming. As you can see, that new bench is just built, if you've watched the new bench video there. So lots of really neat stuff is going to end up on that bench. I have some just monstrous sized gear that I'm going to put on there. Stuff there's no way I could fit in the area right here that I'm working. This is a pretty small area here. So lots of really, really neat stuff coming in the future. All right, enjoy, and I'll see you very soon. Bye for now.